All right, let's get started with Lesson 3, Lewis symbols. All right, this lecture video on Lewis symbols is just the beginning to understand basically what a Lewis symbol is and how to begin to write Lewis symbols. Later on in this unit, we will get more into specifics on Lewis symbols and using them to form Lewis dot structures. All right, so what exactly is a Lewis symbol? A Lewis symbol consists of a symbol of the element and one dot for each valence electrons in an element. All right, so in order to write a Lewis symbol, you're going to need to know how many valence electrons an individual atom has. And then we're going to use a dot to represent each valence electron. Now, elements in the same group are going to have similar electron configurations, and you know that. So hence, they're going to have very similar Lewis symbols, and that's a pretty important connection to make, is that elements that are in the same group are going to have similar Lewis symbols because of their outer electron configuration or valence electrons are the same. However, you need to understand this, that the transition metals, the lanthanoids and the actinides, all have incomplete filled inner shells. And so in general, we cannot write the Lewis symbol for them. That's pretty important to remember. All right, so we're going to take a moment and we're going to write out some Lewis dot symbols for these particular elements. Now, all of these elements that we're looking at are on period 2 of the periodic table, and you should be able to recognize that from its valence electron structure. All right, so let's take a look at the group numbers. So we have group 1 that's represented at 2, 13, 14, 15, 16, 17, 18. Now, we skipped the transition elements again because we really can't write Lewis symbols for those transition elements. So we're only going to use these groups as our examples. All right. So I have the electron configuration. So for group 1, the electron configuration, they're going to have all their valence electrons in the S subshell. And for the second S subshell, this would be lithium. So this would represent lithium. So we would create a Lewis symbol by taking the symbol lithium, and then how many valence electrons does lithium have? It has 1. Like every other element in group 1, there's 1 valence electron. So we're going to place a dot at the 12 o'clock position to represent the Lewis symbol for lithium. Right? So let's go to the next element in period 2, which should be beryllium. Beryllium is in the second group. And how many valence electrons does group 2 have? That's right, they have 2 valence electrons. So we're going to use 2 dots at the 12. We're going to use 2 dots here. 1 dot, and then we're going to add another dot there, and that gives us beryllium. So we're going to place 1 and then 2 dots. And we're just going to kind of work our way around. So by the time we get to group 13, the first element is boron, and so boron's Lewis symbol is B. And then how many valence electrons are in group 13? There are 3 of them. And so we should be able to represent, here, let me actually erase this. I need to write this better. So beryllium, 1 dot, 2 dots, okay? And then boron is going to have 3 dots. 1, so 1 dot, 2 dots, and 3 dots to represent boron. And then carbon is next. How many valence electrons does carbon have? 4. All right, all of group 14 has 4, so we're going to work our way around. 1, 2, 3, and 4. And there's our 4 dots. And then we have nitrogen next. And nitrogen is going to have 5 valence electrons. And so it's got to have 5 dots. 1, 2, 3, 4. And now we're going to start all over again. 5. All right, and there's the Lewis dot symbol for nitrogen. All right. All right, so now let's go over to from nitrogen. What do we have next? Oxygen. And oxygen has 6 valence electrons, so it's going to have 6 dots. 1, 2, 3, 4, 5, and 6. All right. So you kind of see how we're doing this, and then we go to fluorine, and it's going to have 7 dots. 1, 2, 3, 4, 5, 6, 7 to represent its 7 valence electrons. And then finally we get to our noble gas, which is neon. And neon has 8 valence electrons. It has a complete full shell, and so it should have 8 dots around it. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Just like that. So that's how we write the Lewis symbol for these elements. Alright, the last thing we're going to talk about in this lecture video is the octet rule. Now the octet rule we'll refer to quite a bit in this unit and other units later on. The octet rule states when atoms react, they tend to achieve an outer shell with 8 electrons. And this goes back to our previous definition of a chemical bond. Remember that atoms form chemical bonds in order to get a full shell like the noble gases do. And this gives them a more stable or lower energy state. The octet rule is the rule of 8. 8 being the magical number. All these atoms want to achieve an octet, giving 8 valence electrons in its outer shell. And we see that with all the noble gases, with the exception of helium, which only has 2 valence electrons in its outer shell to have a full shell. So not all atoms completely obey the octet rule. Hydrogen, for instance, is probably the most common one that only needs 2 electrons in this valence shell. Fact is, I'm going to write that down so that you remember that. Hydrogen only needs 2 electrons to complete its valence shell. And then lithium and beryllium, as we will learn later, also are going to establish 2 electrons in its valence shell. And we'll talk about why lithium and beryllium do that and how they do that a little later, okay? But for most atoms on the periodic table, the octet rule is applied, that all atoms need to have 8 valence electrons around their outer shell to have a full shell and to be happy and to be content like the noble gases. All right? So that is the octet rule, and this is also the end of this lecture video.